In this video, I'm going to go over 3 of the problems from the mean value theorem homework worksheet, 3 of the problems that are often asked by students in class, and this gives you another opportunity to listen to that explanation. So I'm going to first review what the mean value theorem is asking us to find. We're going to find a value of C. That value of C is between A and B, and it is such that right over here, our left side represents our instantaneous rate of change. So this side, instantaneous rate of change. And the right side deals with our average rate of change. And we want to know when those two are equal. And we are told that they will be equal as long as our function is differentiable. And it'll be equal at a value C that is between A and B. All right, so when we do these, the first thing we want to do is figure out what is the average rate of change. And to do that, in this case, I'm going to do f of 1 minus f of negative 1, because I'm working in the interval from 1 to negative 1, and put that over 1 minus negative 1. So I need to figure out f of 1, so let's do that down here. F of 1 is 1 cubed, which is 1, minus 1 squared, which is 1, minus 2 times 1, which is 2, and that's going to be negative 2. So I'll put that in for f of 1. F of negative 1, negative 1 cubed is negative 1, minus negative 1 squared, which is 1. Let's see, minus 2 times negative 1 is going to be a plus 2, and I see that's going to be 0. So minus 0 over 2, and I get negative 1. The next step I'm going to do is find the derivative, because I want to figure out when that instantaneous rate of change equals the average rate of change. So f prime of x, using my original function, is simply 3x squared minus 2x minus 2. I want to know when that's going to equal this number, negative 1. I see a quadratic. To solve quadratics, we put everything on one side and hope that we can factor. If we can't factor, then we're looking at quadratic formula. But it looks like we're going to be lucky with this one. 3x and x, 1 and 1. Let's see, a minus here and a plus here. That's going to work out so that, let's see, I get 1x here and negative 3x, and that's going to add up to that desired negative 2x. Let's just get rid of that work for a moment. There we go. And so we get 2 answers. One of our answers is when x equals negative 1/3, and the other answer is when x equals 1. The answer we desire has to be between negative 1 and 1, so the answer that we're going for is this one. This is the one guaranteed by the mean value theorem. This answer over here is not between negative 1 and 1, so it's not the one we would use to answer this question. All right, let's try it again. So this time our interval is from negative 1/2 to 2. So we're going to start off with f of 2 minus f of negative 1/2 all over 2 minus negative 1/2. All right, when we plug in 2, that looks simple enough. 2/3 minus, when we plug in negative 1/2, let's just take a little time here. So f of negative 1/2, we get negative 1/2 over negative 1/2 plus 1, and I'm like, oh, this is good. Negative 1/2 over 1/2 is simply negative 1. So 2/3 minus negative 1 over 2 plus, or 2, 2 plus 1/2, and this will be a plus as well. So on top, I get 5/3. On bottom, I have 5/2, and I can do 5/3 times 2/5, and I have an average rate of change of 2/3. And I've taken up an awful lot of space, so we're going to just grab all of that and just shrink it down. So we now want to see when is our derivative going to equal 2/3. All right, so now let's take our derivative. When I look at my function, it clearly is going to need quotient rule. So f prime of x equals, so low d high minus high d low all over low squared. So I get x plus 1 minus x, that's nice, all over x plus 1 squared. And I see that my x's are going to cancel, and I'm going to get 1 over x plus 1 squared. and that has to equal 2/3. Now, when I solve a problem like this and I have a fraction next to fraction, I often think, well, it would be really nice if they had the same numerator. So I'm going to do this a slightly different way. I wish that this one had a 1 on top. So let's see, can I do that? So I'm going to put a 1 right here. Well, then I'd have to also cut the denominator in half. Now, what's nice about this is that if my numerators are the same, I'm going to make sure everyone understands. So if I cut the top in half, 2 cut in half, then 3 has to be cut in half. And I did that so my numerators matched up. If the numerators match up, that means the bottoms must be equal, or the denominators must be equal. So 1.5 equals x plus 1 squared. And next, I'm going to take the square root of both sides. So the square root of 1.5 equals x plus 1. And let's just extend our page here a bit. And then I can just subtract 1. So the square root of 1.5 minus 1 equals x. And I really should have noticed this was going to be plus or minus. So if I look up at the top, I know I want this between negative 1/2 and 2. And if I take the square root of 1.5, that's going to be about 1.225. So this is just as an estimate. 1.225 minus 1. And if I do that, I get 0.225. And let's take a look. Is 0.225 in the region we want? And it is. It's between negative 1/2 and 2. So that's our answer. C equals 0.225. I probably should have checked out the other one. If I did a negative 1.225 minus 1, that'd be negative 2.225. So that was my other option there. And if I look, that's not going to be between negative 1/2 and 2. And so I don't need that option, and I have my answer. All right, let's look at our third one. And our third one, same process. We're going to first start by figuring out our average, and our interval is from negative pi to pi. So we've got f of pi minus f of negative pi over pi minus negative pi. All right, so we need to figure out what these values are. When I do f of pi, I get pi minus 2 sine pi. And sine of pi is just 0, so that's pi. So up here I get pi. And f of negative pi equals negative pi minus 2 sine of negative pi. Well, sine of negative pi is also 0, so that just becomes negative pi. And very quickly I see that I have the same thing on top and bottom, and so my average rate of change is 1. I'm ready to go on to the derivative. F prime of x, simply 1 minus 2 cosine x. And I'm interested in when it equals this value. So 1 equals 1 minus 2 cosine x. Subtract 1 from both sides, and I get 0 equals negative 2 cosine x. I can even divide by that negative 2, so I want to know when does cosine of x equal 0, and I can consider my cosine curve. I'm going to do it that way. So cosine, remember, goes like this and like that. And remember, the region I want is from negative pi to pi. So if I'm going from negative pi to pi, that's this region here on my very poorly drawn cosine curve. And so where does cosine equal 0 in that range? It does so from right here and right here. Remember, this is negative pi here, and this is pi out here. And those values are at pi over 2 and negative pi over 2. And those are our answers. Hopefully this helped as you are looking to finish up the other problem.